So we're talking about arrays. If you create an array full of primitives, that's great. They all get initialized to 0, every element in it. Remember that an array is a series of values all of the same type. Unlike you Python guys who are used to be able to inserting anything that you want to in a list as soon as you create it. When you declare a Java array, or a C++ array, or a C# array, they all have to be of the same type. The elements all get initialized to 0, or their equivalent, Boolean to false. It gets a little bit trickier when you're creating reference types. An array of strings, for example, is not an array full of blanks. If you print them out, you're not going to see empty strings. Instead, you're going to see null references. So if we printed out all 50 states that we see here, we wouldn't see 50 blanks. We would see 50 nulls. We would have to go in and create those strings and assign them. That's different than these, where you could just, create a whole bunch of GPAs, and if you printed them out, you'd have 1,000 floats in a row. But that's because a reference type is a value. It's just pointing out to memory. And if you haven't created an object for it to reference, then instead it's pointing to null, which is 0. So if you want the length of an array, you call .length. I know we've talked about that. There's silly little euphemism here. Acronym. When do you use parentheses with length? You do with strings because it's a method for strings. With arrays, you just call .length with no parentheses, like that. Otherwise, you do what everybody does, which is just type it, and if it's a syntax error, you fix it. But that's the lazy way, isn't it? So why do you need the length of the array? If you're going to print the array out, if you're going to add up all the values that are in an array, get the average of those, stuff like that. You have to know the length of the array. And at least in this language, you do have the ability to pull out the length of the array from the array itself. Unlike C++, where you have to either calculate the length of the array by figuring out its size, or by tracking it, just assigning a constant equal to that you can use over and over. So a partially filled array. Partially filled is when you've used some of the array elements but not all. And why does that happen? Because an array is fixed length. So when you create it, you say, okay, I want to calculate all of the calories I eat every day this month. And so you have to declare it to this largest size that you're going to use in your program, like 31, if you happen to know that this month has 31. And as you're adding them into it, all of that other data is still out there. All those zeros that you initially created it with are still out there. And each time you put a new value in, you're overriding one of those zeros, and you're slowly filling up that array. But there's a whole bunch of data at the end which has not been overwritten yet until you've written out all 31 values. That's a partially filled array. Let's go ahead and create just a little simple array, stick some values in it, and it's going to be a partially filled array. And what's the drag about partially filled arrays is that you can't calculate averages and things like that just based on the length of the array. Right? What if this month only had 28 days, but you had allocated your array out to 31 days, but you wanted to average out only those 28 days? You need to know how many pieces of the array actually have valid data and how many do not. Take out my package statement, move it to the correct folder. All right. So we're going to create an array called WK sales, standing for weekly sales. Double WK sales is equal to new double, and there's going to be 52 weeks in a year. And it's too bad that's not precise. If you type 52 times 7 days in a week, do you get 365? No, you get 364. So our days are always one off each year. January 1st doesn't fall on a Monday every year. Too bad the Earth and the Sun and our rotation didn't, figure that out. So Then we start asking for data. We're going to need a scanner unless we just, randomize some values in there. So we may as well do the whole shebang. Let's include our scanner. Import Java lowercase j dot util lowercase u dot scanner uppercase s. Let's just go into a little loop. Where we ask the user to enter sales, and then we print out the average of the sales so far. So we're going to need a couple of functions for this. We're going to need a function that calculates the sum of the array so far, and maybe we'll just code that directly into the loop for now and worry about making them functions later. So let's use a counter that'll count from 0 to 52. Or 0 to 51 actually, because 0 is the first element and 51 is the last. So int, for int week is equal to 0, week is less than, we could hard code 52, but instead I'm going to make it wksales.length, wksales.length. I'm going to put that on a separate line. It looks funny, but it's easier. And then week plus plus. I've done a syntax error. That was comma was supposed to be a semicolon. Got confused because I broke it up onto 3 lines. If you have it all in one line, it's going to look a lot nicer. Oh, no wonder. I don't have this centered correctly. I am recording, am I not? Yeah. Although my voice looks pretty quiet. Alrighty. Hope y'all can hear me. Increase the volume a little bit. Alrighty, let's ask the user for a sale. System.out.println sales for week end quote plus our week counter. And that's going to say 0, 1, 2, 3, 4, 5, 6, whereas the user would really like for it to say 1, 2, 3, 4, 5, 6, 7, and so on. So we could add 1 to week so it'll look good to the user, but we're computer scientists. We know what week 0 means, so I'm going to leave that alone. So let's get our sales. Double D is equal to sc.next double. Let's put that into our array. WK sales at index position week. I needed to use square braces, sorry. WK sales subscript, and by subscript I mean square braces, week is equal to that value they just typed in. Now let's figure out our average. I've messed up. What did I do wrong? I never created our scanner. So up there where we declare our array itself, scanner sc is equal to new scanner system.in. Let's run it just to make sure we haven't entered any egregious errors so far. It's not going to do much, right? I mean, it's just going to ask us for numbers. Sales for week 0, 12, 14. Great. Okay, so it's working. I'm going to put the entire for loop on one line. I hope y'all have it all now. Guess I could take out some extra spaces. Like that. Alrighty. Okay. So say we wanted to calculate the average. We know how to calculate the average. We know how to get the total. We're just going to rip through that array, getting all the values. So let's do that. We have to declare our total variable or our sum variable. Double total equals 0. Let's put a note saying what we're doing here. Calculate the total. let's use a for loop for int I for index is equal to 0. I is less than, I should just be using 52, right, because it takes so long to type WK sales, but it's better. WK sales dot length, semicolon, I plus plus. And inside our for loop, total plus equals WK sales subscript I. Now, how do you calculate the average? What is the average? It's the total divided by what? By the number of entries, by the number of pieces of valid data. So, let's do that. Double average is equal to total divided by the length of the array, WK sales dot length. No parentheses. And let's print that out. System.out.println total, end quote, plus total. Yeah, we could format it nicely, you know, with %.2f. And system.out.println average plus, end quote, plus average. So if this works, we will get to see the average. Maybe we'll get to see the average, a running average, you know. You enter 10, it'll say 10, and then the next time you enter 5, and you know, those two things average is 7.5. That'd be cool if it works that way. It's not going to, but it'd be cool if it did. Sales for week 0. I sold $100 worth. Average 1. Why does it say that? I wanted my average to be 100 because, you know, I sold 100 that week. Let's enter another one. Sales for the next week, 100. Average of 3, it still ought to be 100, right? Because my total is incrementing correctly. What is going wrong there? It's where we're calculating the average that's the problem. What do you really want to divide by when you're calculating averages? Yeah, the number, not exactly that aren't equal to 0 because somebody really could have 0 sales, but how many pieces of data we've entered. So let's go up here and declare a variable called items. And we're going to start it off at 0, but each time they enter a piece of data, we're going to increment it, right? So we can keep track. Maybe items is a stupid name. Weeks, you know, something like that, but you get the idea. So every time we store something into our array, let's increment the number of items. Then when we calculate, so you see what I did, I added that above our for loop. Inside our for loop, every time we write to the array, we store a value into our array, we increment items. And then down here where we calculate average, let's don't divide by 52, let's divide by the number of items that we've entered so far. That's going to look a lot better. Close that program. Sales for week 0, 1. I did another 1. Average is still 1. 1. And finally I earned 10. Okay, yeah, that's looking much better. Now maybe we only want to calculate the average and the total when they're done entering the data, right? So let's take that code and move it after the while loop. Take the total, take everything from double total is equal to 0 all the way down to those print lines. Or heck, let's do it this way. Cut those and move it after the end while curly brace. But then you'll have to shift that stuff over. Let me rearrange it so that it looks good, and then I'm going to stop and make sure everybody has a chance to catch up. This is part of an end for. I mean, this is part of the for loop, so end for, right? That's our for loop now. And then this stuff goes underneath the for loop. And then eventually down here we have another closing brace, which is the end of main. And then we have another closing brace, which is the end of the class. Just to save space, I'm going to remove these curly braces.
Moving it out of the loop seems to take away the calculation, unless I did something wrong.
Moving it out of the loop should mean that it only does it after we've entered all 52. Now, that's a little bit excessive for testing. So let's, instead of doing 52, let's like do 4. So scroll up to your code, and when we declare our array, change it from 52 to 4 or 10 or however much test data you want to have to enter each time. Because what we've done is we've delayed printing out the average until the loop is done. So come up here and change that 52. Why don't we even make that a constant? Final int max underscore weeks equals, we could have made it 52, but we're going to make it 4. And then double square brackets, WK sales equals new W max underscore weeks. Now everywhere where we use WK sales.length, we could conceivably use max underscore weeks. Not that that's that much, savings of typing. But it's a good thing we didn't hard code 52 everywhere, because if we had, we'd have to go and find every occurrence of it and change it. Here we just have to change it in one place. So sales for week 0, 100, 200, 100, 200. My total was 600, my average was 150. So it's working. But let's give them the option to quit early. And that's going to mess things up again. Let's increase the maximum weeks back to 52. Everybody get all this? I don't want to. Okay. Change that bit back to 52. And then down here where it says sales for week, add another print statement. System.out.println or -1 to stop. And then after we read in the sales, double D is equal, we're just going to check if D is equal to -1, then break. So that's the line that I just added. That's the line that I just added. Or, several of these. Do not add those. You know what I'm doing with those. Just indicating what lines we added. Our average calculator is going to be correct, right? Because we've based our average on the sum versus the number of items. So we actually haven't broken our code yet. So 10, 20, 30, 40. I'm getting really bored. -1. Okay. Average is 25, which is in fact the average of 10, 20, 30, and 40. So it's working. Let's put a little print, a little report down at the very bottom, either before or after our averages. Showing every week in their sales. So what I want y'all to do is write a loop that will print each week's sales. So it'll look like this. 0, tab, 100. You know, week 1, tab, 150. Week 2, tab, 500. That kind of thing. That's what I want your output to look like. And if you make it fancier with .00s and, %.2fs or whatever. So go ahead and work on that. You can do it. You know how to write a for loop. You know how to access elements in the array. It's going to look a lot like this for loop right up there. I'll be right back, gang. Okay. So most of the class already has this done, but what I want to do is I want to print this little report, so I'm going to use a for loop. For int item or week or whatever I want to call my counter is equal to 0, index is less than wk sales dot length index plus plus system.out.println the index counter plus a tab plus the value wk sales subscript index. I'm going to delete these zeros, ones, and twos. And what we're going to find is that it's going to print all 52 values, right? So sales for week 1, 100, 200, 300, -1 to stop. What if I wanted it to stop at the number? This is our partially filled array. It's only got 4 valid values. Thankfully, we already have a counter. So instead of index is less than wk sales, what am I going to set it less than? What was our counter called? That counted how many valid items we had. Items. Yeah. So int index is equal to 0. Index is less than items. Index plus plus. Now it only prints out actual data. And by actual data, I mean data that we've entered. Sales for week 0, 100, 200, 300. Tired of that, -1. And there we go. So that's the problem with partially filled arrays. You don't have to worry about partially filled arrays if you know that your array is completely full. What's an example of a completely full array that you're absolutely sure is full? Don't type this, but this is an example. Strings colors is equal to, R, comma, G, comma, B. There, we've declared an array. We have put 3 items in it. Apparently, I've made a mistake. Okay, not strings, string, square braces. Okay, now we have an array. We've initialized it to 3 values. It's already got its 3 values. It's full. So that's an example of an array, certainly not partially filled. It's really nice to just be able to call dot length and to assume that the array is full. Another example of when you want to be able to do that is when you use a for each loop to print your array. For each assumes that we're going to rip through the entire array. There's no way of breaking. We could mess with this one so that if it found a 0, it didn't print it out. But a for each loop to print out our weekly sales would look like this. For double value colon WK sales. For every double value in the WK sales array, let's print it out. System.out. Let's make it fancy. Printf. We don't have an index counter, so we can't say week 0, week 1, week 2. That's a problem with the for each loop. But we can print out %.2f/n, comma, and then our value. But what's it going to do? It's going to print out all 52 values. So it's nice when our array is completely full. You just have to think to yourself when you're writing your application, is my array completely full or not? Do your best to make sure it is, but if it's something like a data entry and you have no idea how many pieces of data they're entering into it, it's not the best. The real answer to that is to use something else other than arrays. The problem with arrays is that they are fixed length. So you have to you allocate them, and that's pretty much it. This guy is going to be 52 weeks no matter what. If you decide that you wanted to modify it, you want to be able to keep going and add more data past that, well, your array is limited. It only has 52 weeks in it. You can't keep writing past the end of it. So what you want is a dynamic data structure, one that expands as you add values to it. And there are such things. One of them is called the array list. We're going to use array lists. Array lists are implemented using a form of linked lists. So, hope that makes sense. I'm going to hit the PowerPoints again. We're going to talk about what did I really want you to remember, that if you're using partially filled arrays, you have to keep track of how much data the array has in it, or else your results are going to be off. Your printing of your tables is going to be off. Your calculating of averages. And that's a strong argument for not using arrays if you have something else available to you that will grow as the data is entered, which we will get to. I did start the recorder again, did I not? Okay. I didn't like the way this one looked. Well, not that I ever ran it, but 100, 200, 300, -1. I don't like seeing all those. I'm going to get rid of that one. The for each loop is great, but in this particular case, it's not a good way to do it. Why? Because we can't limit it to the number. It's just going to rip through the entire array, pulling out every value. So it's going to have 52 of them, since that's the size of the array that we allocated. It's great for some purposes, not for partially filled arrays. So a partially filled array, you have to keep track of the number of elements in it, a filled element, so that you can process the filled elements differently than non-filled elements. Now, people do funny things in order to get around that. Like, you could set every value in the array equal to -1, right? And if the array had a value of -1, you knew it was invalid and you wouldn't process it. You can mess with things like that, but okay. So copying an array. We have an array here. I didn't have y'all type it in, but maybe I will now, where we created an array of colors. I'm going to go ahead and put the whole words in just because it's cooler looking. Go ahead and type that line of code in. Create an array called colors, an array of string of colors, red, green, and blue. Now let's copy it into a new array. String new colors is equal to colors. Did that really copy the array? The answer is no, and I'm going to spend some time demonstrating that for you. What happens now if we go in and we set the first element of the new colors array equal to something else other than red? Orange. Now let's print out our original array, the original colors array. Or we could write for loops to print them both out. For, it's going to be a for each loop, string s colon colors, system.out.print s plus a space, and then after that let's print out a blank line, so that, because I just use print here rather than print line, that way they're all on the same line. And before it, I'm going to print out a name for this array. Print line colors array. Then copy that and change it to print the new colors array. You're just going to have to change two things, right? You got to change that variable right there, and you're going to have to change your description right there. So I'm going to copy that printing code, paste it here. I printed out the colors array, and now on the second for loop, I'm printing out the new colors array. You see what I changed there? Change that line right there to new colors. Let's run it. What I'm going to, okay, great, 0. What I'm going to see, I'll change that print ln on colors array and new colors array just to be print so it doesn't go to the next line. Right, system.out.print colors array, system.out.print new colors array. Trying to make it look nice. Alrighty, -1. Alright, so the colors array, orange, green, and blue. New colors array, orange, green, and blue. Is that what we wanted? Is that what we told it to do? I thought we only set new colors. I thought we only changed that array. So why, when we printed it out, did it say that the first element of the colors array was also orange? Anybody want to take a stab at answering? The answer is that new.
Because in the array it goes 0, 1, 2, right? That's
Right.
sectors.
But the problem is that they're the same memory. It's like two street signs pointing to the same house. You go and you paint your house blue, then both street signs are now pointing towards a blue house. These are both pointing to the same array space. This did not actually create a new array with new memory. All it did is create a reference that's pointing to the same place that this pointed to. To get this to actually work so that we can change new colors without modifying the original, we need to actually copy that code, that array into the new one. And there are ways to do that. There's like 3 arrays to do it. We're going to do it by hand the first time. We all have it compiled and running, so we don't have to go back and fix it. We all good. All right, so let's do that. We don't need to set it equal to the colors reference because that's just like having two street signs point to the same house. It doesn't do any good. What we need to do is follow these steps. Allocate a new array to the same length as the old. Then use a loop to copy the elements from the old loop, old array, into the new. So that allocate part's pretty easy, right? New colors is equal to new string, and I need to put some number in here. I just put 3 because I happen to know, but that's not the right thing to put. What should I put there? Because what if I later on went back and added more colors to this colors array? 3 is no longer a good value because I want it to be the same length as that one. So what should I put there?
Colors.length.
Yeah, let's do colors.length. We want both arrays to be the same length. Now we have done this part. We have done that. Yay, that one's done. Use a loop to copy the elements from the old array into the new one. Okay, so for int I is equal to 0, I is less than colors.length, I plus plus, new colors, subscript I, is equal to colors, subscript I. Now we don't just have 2 references to the same memory, to the same array, we actually have 2 separate arrays. So when this code cooks along and changes that element to orange, our original array is still going to say red there. And yeah, there's a warning over here, and it's wanting us to convert this into something else. I'm going to go ahead and do it, and then I'm going to undo it. Replace with system.arrayCopy. Yeah, you could do it with a single call to something called arrayCopy. But I want you to have the idea. Allocate a new array the same length as the old, then copy the values in with a loop. That's what you do. And you can be sure that that system call is doing the exact same thing. All right. Okay, so our colors array, red, green, blue. Our new colors array, orange, green, and blue. So it worked. We have two different arrays, not just one array with two references. I hope that idea of two references to the same thing makes sense. The best I can come up with is two street signs pointing to the same street. It's the same street. If you, go in and paint all the houses on that street red, you have two street signs pointing to a whole bunch of red houses. You don't copy the street just because you put up a new street sign. This here, when we said is equal to colors, does not create a copy of the colors array. It doesn't go out and allocate new space for all those elements. Because this is just a number, actually. Colors is just a number that's pointing out to with a memory address in it. And when we do that, we're creating a new variable, but it has the same number in it. It has the same memory address. Two people looking at the same list of stuff. All right. Probably belabored that too much. Whoopsie. Okay. Go in. Surely there's more important stuff to talk about than histograms. Searching an array. Searching an array, you need to start at the beginning and you keep running through the array until you find the one where until you find your value. Or if you never find it, you go all the way to the end and you say, hey, I didn't find it. So, let's create an array of numbers and then names, and then let's find the position of the specific element that we're looking for. We're going to search the array and we're going to find the index value of the one that we actually were looking for. So our sales array up here. We're going to search that array for the value 100. And if we find a week where we sold $100 exactly, great. We're going to print a message and we're going to stop there. Nah, let's declare a new array for our example. We already had one called colors. Let's do one called names. String names. Nah, let's do numbers. Int. An array of ints, nums, is equal to 8, 3, 4, 16. Just type some numbers in. Doesn't matter what they are. Let's print that array out using a short form command. Now, if I ask you on the exam to print an array using a loop, don't do it this way. But system.out.println nums equals end quote plus arrays dot toString, and then pass in our nums array like that. That's a short way of printing the array. And as I said, you have to know how to do it with a loop if you want to get credit on the exams, but for test purposes in our program, that's equally good. Now let's find, in my case I had the number 23 in my array. So that's going to be my target. I want to find the value 23. If you didn't put a 23 in yours, either add one or set your target equal to something else. Now we need to start at the beginning of the array and keep looking until we find a 23. We could use a for loop. The book shows using a while loop. I like for loops too much to stop now. So for int I is equal to 0, I is less than nums.length, I++, if nums subscript I, and I forgot my parentheses, sorry. If parentheses num subscript I is equal to our target value, great, we found it. So system.out.println, we found plus target. This isn't very good because it doesn't let us know if we never found it. So we're going to write a better version of this pretty soon. We just want to make sure that this works first, though. Yeah, and we did find a 23. Here's our array. There's a 23 in it. We did find it. What do we really need to know, though? We need to know the index number of it. Like if we wanted to change that 23 to something else, if that's why we were doing a seek, we would need to know its index number. And if we don't find it at all, that's also useful information. So we need some variable that contains the index number of where we found it. So I'm going to call it found at. I'm going to go above my for loop and do this. Int found at is equal to, and I'm going to set it equal to -1 because that's an invalid value, right? That means we never found it. But if we ever do find it, great. We're going to set found at equal to our index, our counter. So I just added that line. And I added that line. Those are our new lines of code. And I'm going to take this system.print out. I'm going to use it down here. If found at is equal to -1, it means we never found it. So system.out.println never found plus target. But if it's greater than -1, because of that line, I'm going to take the curly braces out of that. If we did find it, hot diggity, let's print that out. System.out.println found I'm going to use %f just because it's so much more concise. Sorry. Found %d at index %d \n end quote comma target comma found at. That's a very common, that's an algorithm to remember. You just start at a loop, you keep looking until you find the value. Now we're going to optimize it in a minute. We're going to make it a little bit better. But let's make sure it works. Found 23 at index 6. And if I count 0, 1, 2, 3, 4, 5, 6, that is correct. It found it. Let's look for a number that doesn't exist. Change your target number to something that doesn't exist in the array. If y'all have these print line statements, okay, I'm going to put them all in one line. Everybody have the prints okay, or am I messing you up by doing that? Waggle your fingers if you don't want me to change the print statements. All right. Why am I doing that? So I can take these curly braces out. Okay.
It's the fifth one in the array. That should be index 4, correct?
Right. If you're looking, well, if I was looking for 1, 2, 3, 4, if I was looking for 34, that's index 6. No, 4. 0, 1, 2, 3, 4.
Okay.
Yeah.
Well, mine's at the 5th position, but it's saying it's index 5.
I'll be right over after I prove that if I change this to something that doesn't exist, says that it didn't find it. Okay. So target is equal to 100. I know I don't have any 100s in my nums. So when I run it, it says I never found the 100. All well and good. That's what I wanted it to say. So one student's having a problem with arrays. I'm going to highlight and do show Java doc, and we're going to find out what class it's in. It's in java.util.arrays. We're going to add an import for that. Now, as to why it worked for me and some people and not for you, that's a good mystery. But scroll up to the top, and if this has not been working for you at home the entire time, oh, I must have just clicked some OK message or something and had it inserted. I don't remember doing that. But anyways, add that line to it, and you'll be good to go.
Yeah, the first time when you do your for loop, and then the first time that you click on the little deal to convert it to show us this, and then you brought back the for loop, it took back the sentence, but it didn't take back your import.
Okay.
So it automatically got it.
Okay. All right. So now we know everything we need to know about arrays, but I promised we were going to do one more thing, which is what happens if you have 10,000 elements in this array? Do you really want to search all the way to the end of the array if you've found it? What if I was looking for an 8, you know? 8's the very first thing in my array. Do I want to keep going out to 10,000 even though I found it? There's more than one way to handle it, but there's a really easy way to handle it. How can I make it stop as soon as I found the right value?
Put a break right after.
Yeah, that's the easiest. It's just to put a break here. So inside our if nums I is equal to target, I had removed my braces, you probably didn't. Found at is equal to I, which is where we found it, and then break. That way we don't just keep running to the end. You can get huge efficiency savings, by doing that. On average, if you're doing searches into an array, and the array is of length n, then the number of seeks you have to do is n divided by 2. But if you had to go all the way into it in the very end, then the average would always be n. So by doing that, you save your average seeks. You cut them by half. All right, let's stop there. Let's see if we have homework that we need to queue up. So here's the homework assignment. You can just go to the Dropbox and read it, or pause it and read it here.